Okay. So let's look at the example 1. After this discussion, this should be straightforward. A block is at rest on a horizontal surface. The maximum static friction is 50 Newton. What is the static frictional force if you pull it horizontally with 30 Newton force? A. B. 60 Newton force. So for A, what is the answer? If I pull it with 30 Newton force, what is the magnitude of the frictional force? 30, 50, or 60? Or 0, maybe.
If you pulled with a 30 Newton force, it wouldn't move, right?
Okay, so I'm just saying that the system can give you the maximum static friction at 50 Newton. Now I'm putting it with 30 Newton. What is the actual frictional force? 30, right? Because the system can provide you 30. And this 30 is enough to compensate the 30 Newton external pulling. So in that case, then what happens? So the system is very lazy. It will only give the force enough to compensate the external pulling. Now, question B, if I pull the object with 60 Newton force, what is the static frictional force?
50.
50, okay, because the system tried to compensate the 60 Newton external force, but it cannot do that. It can only give you 50, so it will give all the 50, even it still cannot prevent the motion. So the answer A, 30 Newton frictional force, static frictional force. B, 50 Newton static frictional force. Okay. So, any question here?
You just said A would be 30
Yes.
because it's under the maximum.
Okay, so because it's under 50 and x equals to external 30. Okay. But for B, he tries to give 60, but he cannot. He will can only give 50. Now, example 2 is about the direction. Okay. For the following configuration, assuming all the surfaces are frictional and blocks are not moving, okay, we're talking about static friction. Identify all the frictional force acted on the two blocks. Okay? All the surfaces are frictional, so and this surface you may have some frictional force, and this surface you may have some frictional force. Now, if I'm putting the bottom box with some external force, and it's not moving, okay? So let's identify how many frictional forces acted on object 1, how many of frictional forces acted on object 2, okay? So, okay, let's do it one by one. Can you give me any frictional force you can make sure, you're sure? Okay, or give me any frictional force you can identify.
For static in the opposite direction of the force applied.
Acted on which object and which surface?
Object 2, ground surface,
The surface. Okay.
opposite direction of force applied.
So this is one frictional force. Okay.
If the force is enough for it to move, won't there be a static friction between 1 and 2? If number 2.
Yeah, this is the static friction force. That's easy. So and the surface. Do we have any frictional force on the surface?
Yes.
No.
So okay, if you say what is the frictional force acting on 2? Which direction?
It would be in the direction of force applied.
So you say and 2, you have this kind of frictional force.
Okay.
How about 1? Wait.
Wouldn't that be a
Wait.
So if you have this kind of frictional force, then why have this kind of frictional force? Is it correct? This cannot be correct because if you this is case, that indicates one has to move backward. Okay, but we say both of them are stay there. So actually, in this case, if both blocks are not moving, you have only one frictional force here. Okay.
Do you have normal force?
Yes. But I only here I'm only asking about your frictional force. Of course, you have all the normal force. Any question here? Okay. So this kind of you can think about this is just trying to pull both together, but this is not moving. It wouldn't affect block one. Okay. Now, if I'm pulling the upper block with some force F1 and 2, so how many frictional force do I have in this case? Or okay, just so let's do one by one. Tell me anyone you can identify so far.
Friction
Force
between 1 and
static
2.
between 1 and 2.
Static frictional force between 1 and 2 acted on which
Opposite.
object?
Acted on object 2
In which
No.
direction?
against
That's not
force
object
applied
one.
So
Opposite
you
motion.
say which surface?
of the surface 1.
Here, so you say there is some surface and 2 like this. Anything else?
Between two.
2 in the ground.
Between
Hmm?
So in 2 in the ground.
In which direction?
against
Opposite to what?
force applied.
Like this? Is it correct? If this is correct, object 2 will move to this direction, right? Okay, not like this. Okay. Let me do this way so you wouldn't miss it. So first, when I'm pulling, you can think about the process. Okay. When I'm trying to pull it to that direction. So that means the object 1 try to move to that direction. So it immediately will give you some frictional force acted on 1 from the surface. This is the force to prevent it from motion. Okay. Now, if this is the frictional force from 2 give to 1, so that means it must have some reaction. Okay. Acted on 2 in this direction. This is the frictional force acted on object 2 from box 1. But now, that means I'm pulling box 1. And due to the frictional force, box 2 try to pull the box 2 to that direction. But if it's not moving, then there must be some frictional force here to prevent it. Okay. Any question here? If you look at the whole system, you can try to identify, try to understand like this. If you only look at box 1, it's this frictional force to compensate the external pulling. If you look box 2, what happens is that box 2 doesn't feel the external pulling. It will feel 2 frictional forces, one from box 1, one from ground. The 2 frictional forces cancel each other. If you look at the whole system, then you don't need to look at the action and reaction. It's the frictional force compensates the external pulling. Okay. So that's one way to understand. Another way is just to follow the order I'm trying to say. This force cause this frictional force. This frictional force causes this frictional force. And this frictional force causes this frictional force. Any question here? Please compare the two situations. So here, for this kind of problem, it's very important to isolate the object. So So you know what's the frictional force between them.
In the first system, is block one moving with block two, or is it staying?
Both of them stay in the same place. Okay. So it wouldn't propagate any force to one. Or in another words, when I'm trying to put box 2 with some external force, because he can get the frictional force from the ground, that's enough if it's not in motion. So it doesn't bother to ask for some frictional force from box 1. But for box 1, it's different. If I'm putting box 1, it has to get some frictional force from box 2. So it will introduce a bunch of frictional force like that. Okay? Okay.